Hi listeners, you are welcome to the continuation of our physics tutorial class from your favorite student ScoreBooster, your online tutorial provider on JAM, UTME, WAEC, NECO and NAPTIP exam. For today's presentation, we shall be discussing the concept of relative density. I am Vanguarde AA. Now, before we proceed, we need to consider the learning outcomes of this particular presentation, which goes thus. At the end of this presentation, listeners should be able to define relative density, that is RD. They should also be able to state the formulas for calculating relative density of a substance. They should also be able to state another name for relative density, and lastly they should be able to solve relevant UTME questions relating to relative density. To the concept of relative density. Relative density is usually represented by RD. It is also known as specific gravity. And the relative density of a substance is the ratio of the density of the substance to that of the water. I repeat, relative density of a substance is the ratio of the density of the substance to the density of water. If the density of a substance is equal to D and dW equals density of water, then we can say the relative density equals D over dW, which will also be equal to the weight of the substance over weight of equal amount of water, which is also equal to mass of the substance over mass of equal amount of water. It can also be equal to volume of substance over volume of equal amount of water. I repeat, for relative density, it can be calculated by using density of the substance over density of equal amount of water, then or weight of the substance over weight of equal amount of water, or mass of liquid displaced over mass of equal amount of water, or volume of liquid displaced over volume of equal amount of water. Then we should also take note that the relative density of water is 1.0. And lastly, we should take note that all metals and most solids have relative density greater than 1, while air and several liquids have relative density less than 1. So all these are very important concepts and formulas which we shall be applying in solving our calculations later. Now on to sample questions from UTME. The first question we shall be considering comes from 1980, number 30, and the question goes thus: the relative density of zinc, brass, copper, gold, and silver are respectively 7.1, 8.5, 8.9, 19.3, and 10.5. A metal ornament which weighs 0.425 kg and can displace 50 times 10 raised to power minus 6 meter cube of water is made of dash. So you have option A to be zinc, B is brass, C is copper, D is gold, and E is silver. Now on to solution. The first thing is to write out the given parameters, and from the question we are given the mass of the substance to be 0.425 kg, and we are also given the volume of water displaced to be 50 times 10 raised to power minus 6 meter cube. And according to principle of flotation, it said a solid will displace its own weight of the liquid in which is the mass. So we assume the volume of water displaced will be equal to the volume of the substance itself. So then we have to recall that the density equals mass over volume. You know, from our previous video 17 under density, we discussed that. I urge my listeners to please refer to our video 7 for necessary foundation on density. But here now we borrow the formula density equals mass over volume. So D equals m over v. Then when we substitute now, the density of the substance will be m, that is the mass, which is 0.425 kilogram, divided by the volume phi, which is given to be 50 times 10 raised to power minus 6 meter cube, and that will give us 8.5 times 10 raised to power 3 kilogram per meter cube. That is the density of the substance. But we have to recall that relative density equals density of the object over density of water. Then when we substitute for that, the density of the object is what we just got, that is 8.5 times 10 raised to power 3 kilogram per meter cube, divided by density of water, which is 1000 kilogram per meter cube. So 1000 will cut 10 raised to power 3 away, so we have 8.5 left as our answer, making option B the correct answer for this particular question. The next question which I will be considering comes from 1991, number 12, and the question goes thus: the mass of a stone is 15.0 gram when completely immersed in water, and 10.0 gram when completely immersed in a liquid of relative density 2.0. The mass of the stone in here is option A 5.0 gram, option B 12.0 gram, option C 20.0 gram, option D 25.0 gram. Then now on to solution. You have the mass in water to be equal to 15 gram, that's the given parameters. Then also we are given mass in liquid to be 10 gram. Then they ask us to find the mass in air. Then we have to recall that the relative density equals mass of liquid displaced over mass of water displaced, and that will give us the RD, relative density, is 2, which is equal to mass of liquid displaced will be the mass of the object in air minus mass in liquid, then over mass of water displaced, which will be the mass of object in air minus mass of object in water. So since the mass in here is unknown, we represent it by m. Therefore we have 2 equals mass in here, which is m, minus mass in liquid, which is 10, over mass in here again, mass of the object in here, minus mass of the object in water, which is 15. Then we have to cross multiply to get 2 into m minus 15 equals m minus 10. Then open the bracket and collect the like times. We have 2m, 2 times m will be 2m, minus 2 times 15, which is 30, equals m minus 10. Then collect the like times, that will give us 2m minus m equals 30 minus 10. So giving us m equals 20.0 gram, making option C the correct answer for this particular question. Now the next question which I will be considering comes from 1994, number 18, and the question goes thus: the mass of a specific gravity bottle is 15.2 gram when it is empty. It is 24.8 when filled with kerosene, and 27.2 gram when filled with distilled water. Calculate the relative density of the kerosene. So we are given option A to be 1.25, option B to be 1.10, option C to be 0.90, and option D to be 0.80. Now on to solution. The first thing, as usual, is to write out the given parameters. So now we are given the mass of the empty specific gravity bottle to be 15.2 gram. Then we are given the mass of the bottle when it's filled with kerosene to be 24.8 0.8 gram. Then when it's filled with distilled water, it is 27.2 gram. Now, the mass of kerosene will be the mass of the bottle when filled with kerosene minus mass of empty bottle, and that will be mk minus me. That will give us 24.8 minus mass of empty bottle, which is 15.2. So making the mass of kerosene to be 9.6 gram. Similarly, we can get the mass of water by subtracting the mass of the bottle plus water minus mass of empty bottle. I mean, the mass of water will be the mass of the total mass of the bottle when filled with water minus the mass of empty bottle, and that will give us 27.2 minus 15.2, that is 12 gram. Now that we know the mass of kerosene and mass of water, we have to recall that one of the formula for calculating relative density will be the mass of the substance over mass of equal volume of water. Therefore, our relative density RD in this case will be mass of kerosene over mass of equal amount of water, and that will give us mass of kerosene, which is 9.6, divided by mass of water, which is 12. That will give us 0.8, making option D the correct answer for this particular question. And the next question we shall be considering comes from 2008, number 16. And the question goes thus: in Yes apparatus, water rises to a height of 26.5 cm3 in one limb. If a liquid rises to a height of 20.4 cm3 in the other limb, what is the relative density of the liquid? Now, we're given option A to be 0.8, option B is 1.1, option C is 1.2, option D is 1.3. Now on to solution. The first thing is to write out the given parameters as usual. So we're given the height of the water and the height of the liquid. From the question, the height of liquid HL is equal to 20.4 cm3, while the height of the water HW is equal to 26.5 cm3. Now, we have to recall that our relative density equals the volume of the liquid over volume of equal amount of water. So in this case, our relative density will be the height of the liquid over height of equal amount of water, and that will be RD equals HL over HW. Our HL, which is the height of liquid here, is 20.4, divided by HW, which is the height of water here, is 26.5. So 20.4 divided by 26.5 will give us 0.7667, which can be approximated to be 0.8, making option A the correct answer for this question. Now on to practice questions from the UTME. The first question for your practice here comes from 2006, number 14. And the question goes thus: if the relative density of gold is 19.2, the volume of 2.4 kilogram of gold is dash. So you are given option A here to be 1.9 times 10 raised to power minus 4 meter cube, option B to be 4.61 times 10 raised to power minus 3 meter cube, option C is 8.00 times 10 raised to power minus 3 meter cube, option D is 1.25 times 10 raised to power minus 4 meter cube. Then density of liquid equals density of water here equals 10 raised to power 3 kilogram per meter cube. Expected answer here is 1.25 times 10 raised to power minus 4 meter cube. That is option D. Then the second question for your practice comes from 1997, number 19. And the question goes thus. An empty 60-liter petrol tank has a mass of 10 kilograms. Its mass, when full of fuel of relative density 0.72 is dash. Yeah, option A here is 7.2 kilogram. Option B is 33.3 kilogram. Option C is 43.3 kilogram. Option D is 53.3 kilogram. Expected answer here is option C, which is 43.3 kilogram. Now, our next video will be on Archimedes principle with sample questions and solution from the UTME. I urge you to please subscribe to our YouTube channel, like and share our videos, as we promise to be providing you with more interesting lecture relating to UTME, especially physics. Thank you.